Welcome class 8th. Today we will continue with exercise 12.1. It's chapter number 12, Exponents and Powers, from your NCERT textbook. We have already done the first 5 questions. Question number 6. First part, we've been given 1 by 3 raised to the power minus 1 minus 1 by 4 raised to the power minus 1, and together these two terms in a bracket and whole bracket raised to the power minus 1. So the rule to simplify brackets is start with the one which is the innermost. The smallest bracket, which is the innermost bracket, will be solved first, and then we move further outside. So right now we will be solving these two round brackets. To solve these two round brackets, we want to solve the exponent, which is a negative number, but we cannot solve a negative exponent. We would first like to convert it into a positive exponent, and then we can simplify. To convert a negative exponent into a positive exponent, we need to write down the reciprocal of the base. So the base here is 1 by 3. Its reciprocal will be 3 by 1. And the power from minus 1 becomes plus 1. Same thing will happen to the second term. The base is 1 by 4. When I write the reciprocal for this, the power minus 1 will become plus 1. So this becomes 4 by 1, the reciprocal of 1 by 4, and the power becomes plus 1. But this curly braces, the power minus 1, no change to this yet. Let's work on these round brackets. Anything raised to the power 1 is same. Minus 4 raised to the power 1 stays 4. Whole of this expression raised to the power minus 1. So answer from this bracket comes out to be minus 1, and this is raised to the power minus 1. Again, to solve the negative exponent, I have to write down the reciprocal of base. The reciprocal of minus 1 will be, minus 1 can be written as minus 1 over 1, and its reciprocal will be 1 over minus 1. So this one comes to the numerator, negative 1 goes to the denominator. Still 1 over 1 is 1, and this negative can be written here. So the reciprocal will be minus 1, and the power becomes positive, and any number raised to the power 1 is itself. Let's do the second part. We have 5 by 8 raised to the power minus 7 into 8 by 5 raised to the power minus 4. Now to simplify this, we would like to use laws of exponents. But the laws of exponents can be used in two cases. Either the bases should be same depending on the operation between the two values. If the base is same in division, we subtract the exponents. If the bases are same in multiplication, we add the exponents. But it could happen the opposite way also. The powers could be same. If the powers are same in division, we divide the bases. If the powers are same in multiplication, we multiply the bases. In this part, nothing matches. Neither the base matches nor the exponents match. But if you observe closely, you can see that the bases actually are reciprocals of each other. The first base is 5 by 8 and the second base is 8 by 5. These are the reciprocals of each other. The place of numerator and denominator has been interchanged. What I can do is I can write down the reciprocal for either the first one or the second one. Then the bases will match. Then I can apply the laws of exponents. Just remember, change only one, don't change both. So I'm changing the first one. What happens is, every time you write down the reciprocal of base, the sign of the exponent changes. So I have written the reciprocal of base. My exponent becomes plus 7. Earlier it was minus 7. The sign changes. There is no change to the second term. Now I have same base. I can apply my laws. Same base. In multiplication, powers will be added. So 7 and minus 4, these two will be added. So this gives you 8 by 5 raised to the power 7 minus 4, which is 8 by 5 raised to the power 3. Simplify. 8 by 5 multiplied with itself 3 times. You could give the simplified answer. This gives you 512 over 125. Now let's do question number 7th. Question number 7th from the same exercise. First part, 25 into t raised to the power minus 4 over 5 raised to the power minus 3 into 10 into t raised to the power minus 2. Along with this, they have given this condition that t cannot be 0. T is not equal to 0, and this is required because the variable t is appearing in the denominator, and in a fraction the denominator can never be 0. If t becomes 0, we will have 0 in the numerator, 0 in the denominator, and the fraction would be 0 by 0, which is not defined, or you can simply say it's meaningless. So we have to make sure that the denominator is not 0. That's why they have written the variable t cannot be 0. For simplification, it serves no purpose. Let's simplify. Now, for simplifying expressions like these, we would like to separate the terms with similar bases. You can see that these two terms, the term from the numerator and the term from the denominator, these two have the same base. So these can be separated. But as for the remaining part, the base don't match. So what I would like to do is, I would like to change my composite numbers into exponential numbers. That will be your first step. So 25 can be written as 5 square. 10 can be written as 2 into 5. This is obtained with the help of prime factorization. This is something you learned last year, to write any composite number in the exponential form. And that can be done by prime factorization. I'll be using these exponential values in place of 25 and 10. So my expression becomes 25 replaced by 5 raised to the power 2. In the denominator, I already have 5 raised to the power minus 3. No change to this value, t raised to the power minus 4. 10 replaced by 2 raised to the power 1 into 5 raised to the power 1. Into the third value in the denominator stays the same. Now it's time to separate the terms with same base. So first of all, I'm going to write down these two terms, the ones with base 5, but do not change their places. The one in the numerator will stay in the numerator. The value which is in the denominator will stay in the denominator. So what do we have? 5 square over 5 raised to the power minus 3 into, since this term is, okay, I missed this, I also have 5 raised to the power 1 in the denominator. So 5 raised to the power 2 in the numerator. In the denominator there are two terms with base 5. Then the second term is with base 2, but I don't have any term in the numerator for which the base is 2. So I can simply write it as 1 over 2 raised to the power 1. Then I will write the terms with base t, t raised to the power minus 4 over t raised to the power minus 8. Now simplifying these separately using laws of exponents, I will work with the denominator first. Let's simplify the denominator. In the denominator, I have multiplication of two exponential values in which the base is same. In multiplication, when the base is same, the powers are added. So minus 3 plus 1. No change here. 2 raised to the power 1 is 2. Over here, since this is division, the base is same, so the powers will be subtracted, and the powers will be subtracted in the same order. The power from the numerator, the power from the denominator, subtracted. Simplifying further, over here the numerator stays 5 square. In the denominator, I get 5 raised to the power minus 2 into 1 by 2 into t raised to the power. Simplifying this, minus 4 plus 8. Now apply the law of division exponents here. This is division, base is 5, the powers will be subtracted into 1 by 2 into t raised to the power 4. So this becomes 5 raised to the power 4 into t raised to the power 4 whole divided by 2. You can simplify this if you want. Just remember, in case the exponents are large, do not simplify, leave it in the exponential form. So this gives you the answer as 625 into t raised to the power 4 by 2. Okay, now let's do the second part of question number 7. We have 3 raised to the power minus 5 into 10 raised to the power minus 5 into 125 over 5 raised to the power minus 7 into 6 raised to the power minus 5. Now the first step is to change all the composite numbers into exponential form using prime factorization. So I've got a composite number here, 10. The second composite number is here in the denominator and the third one is here in the numerator. Let's prime factorize these and obtain their exponential forms. You can separately prime factorize these numbers. You will obtain that 125 equals to 5 raised to the power 3. 10 equals to 2 raised to the power 1 into 5 raised to the power 1, and 6 is 2 raised to the power 1 into 3 raised to the power 1. Now let's use these values here in our expression. We get 3 raised to the power minus 5. First term, there is no change. Second term, the encircled value 10 can be written as 2 raised to the power 1 and 5 raised to the power 1, the product of these two. But 10 had an exponent minus 5, so this bracketed value will have the exponent minus 5. 125 can be written as 5 raised to the power 3. In the denominator, the first term, no change. The second term, the encircled value 6, can be written as 2 raised to the power 1 into 3 raised to the power 1. And since this encircled value had exponent minus 5, the exponent for this bracket will also be minus 5. Let's simplify. The first term is 3 raised to the power minus 5. Opening the brackets, two terms which are multiplied together and together their power is minus 5. So each of these values will have the power minus 5. The power will be given to each of the numbers. And 2 raised to the power 1 is 2. Power 1 can be ignored. Power minus 5 for this term into 5 raised to the power 1 is 5, and this power minus 5 assigned to it. The last value is 5 raised to the power 3. In the denominator, I've got 5 raised to the power minus 7 into, let's open the brackets. Since both these numbers have exponent 1 can be ignored, but the exponent outside the bracket, which is minus 5, will be given to each of these. So the first value is 2, exponent minus 5 given to this. The second value is 3, exponent minus 5 given to this. Now I reorder and collect the terms with same bases. Let's begin with the terms with base 3. So this is the first term with base 3. I've got another term over here. So let's bring it over here. Since this was in the denominator, I'm keeping it in the denominator. Next term will be the terms with base 2. So I've got this term from the numerator, the base is 2. This term from the denominator, the base is 2. Then I will collect the terms with base 5. From the numerator, I've got 5 raised to the power minus 5. Another term, 5 raised to the power 3. In the denominator, there is just one term for which the base is 5. Now let's solve. Same value over same value. You can either cancel here, this will be 1, or you can apply laws of exponents. So this will be division, base same, powers will be subtracted. Same goes for this one. This is division of two values, same base, the powers will be subtracted. So minus 5 and minus 5 subtracted. For this one, I would like to simplify my numerator first. So the numerator, it's multiplication, same base, the powers will be added. In the denominator, I have 5 raised to the power minus 7. So this becomes 3 raised to the power minus 5 plus 5 into 2 raised to the power minus 5 plus 5 into 5 raised to the power minus 2 over 5 raised to the power minus 7. So further, this can be written as 3 raised to the power 0 into 2 raised to the power 0 into, applying the law here, division, base is 5, the powers will be subtracted. So from here, what do we get? 3 raised to the power 0. Any non-zero number with power 0 gives you 1. Any non-zero number with power 0 gives you 1 into, simplifying this, minus 2 plus 7. So this is 5 raised to the power 5. Any number multiplied with 1 gives the answer as itself. Simplifying this, multiplying 5 times with itself gives you 3125.